So, how about the force between current carrying conductors placed side by side? So the force between current carrying conductors placed side by side to each other. What happens? You know, in one of our last topics, we said if you have current flowing in a conductor, then you have generated around itself a magnetic field. And like we're going to be seeing much later, when you have a changing magnetic field, current is also produced. So these two are usually these two phenomena actually accompany one another. So if you have two conductors placed side by side to each other, let's say now you're looking at the conductor from two ends, just from the ends like this. These are two metallic conductors. Now, if you pass current through them in the same direction, okay, now let me see. We have two conductors this way. You're passing current through them in the same direction. The current is flowing this way. Oh, sorry, let me not put it this way. Okay, let's say we have two conductors placed side by side. Now, this is like you're looking at it from one end. You have two conductors this way, placed side by side. So what you're seeing here is actually you looking at it from the tip, from the top. Okay, so what happens? Now, if you pass current through them in the same direction, it means because the two of them will be in, sorry, okay. So like I told you earlier, let's say we have two conductors here, and these two dots you're seeing here represent the two conductors such that you'll be looking at them, you're actually looking at them from the tip this way. You understand? But they're actually a conductor like this. Now, if you have them placed side by side to each other, when you pass current through a conductor, then you generate around itself a magnetic field. So as these two conductors are being passed current in the same direction, then the pattern of magnetic field around it will be such that the force between them will be that of attraction. The magnetic force between them will be that of attraction if the current is being passed through them in the same direction. And we have an ion filing this way. Let's say you have let's put it this way. This is actually what I'm talking about. You see? We have two conductors, and then you spray some ion filings around it here. If you pass current through these two conductors in the same direction, the pattern of magnetic field is shown below. And that shows that there will be a force of attraction between the two current carrying conductors. Now, what happens when you pass current through them in opposite directions? See, in opposite directions. So, we have the pattern of magnetic field goes in this way. So we have repulsion instead. So while in this case, if you pass current through them in the same direction, the magnetic force you tend to have between them is that of attraction. When you spray an iron filing around it, the pattern of magnetic field given to you will always appear in this form. And then when you do the same thing, when you pass current through the two conductors in opposite directions, this is the pattern of magnetic field you get, showing a repulsion between the two current carrying conductors. So this is what happens when you pass, when you place current carrying conductors side by side with each other. You see, when you do that and you pass the current in the same direction, you end up having the magnetic force you have between them will be that of attraction, while when you pass the current in opposite directions, you get a repulsion. You see. So, what about the motion of current carrying loop in a magnetic field? You see, let's say we have, magnetic field has two polarities, right? We have the North Pole and we have the South Pole. Let's say we have a loop like this. And the loop has an axis of symmetry. Let's say we have A, B, C, D. Okay, when you have a loop like this in a magnetic field, of course, here we have magnetic field. You have the magnetic lines of force running from north to south. Now, if you decide to pass current through this place, if you decide to pass current through it, there will be a force acting on this side. There will be a force acting on this side, pulling it upward, while there will be a force acting on this side, pulling it downward. You see? So, and that means these two forces, these two opposing equal but opposite forces will constitute a couple, turning this upside down, turning this in this direction, this current carrying loop in this direction, you see. And as that happens, this will now change, and then there'll be a force acting on this side now downwards, while there'll be another force acting, that is AB will change to this side, while CD will change here. So, and as that happens, there'll be another force acting on the CD downwards again, and then forces acting on them, a force acting on AB upward. So these two forces will constitute a couple, rotating this coil within this magnetic field. So that's what experiment will show you. That when you place a current carrying loop in a magnetic field as you see here, then you're going to produce on it a couple, two forces acting on both sides of the coil, rotating it within the magnetic field. And of course, it's the same thing that happens if you replace this loop with just something like this. If you replace this, okay, here we have North Pole, South Pole. A, B, C, D. And of course, you have magnetic lines of force like this. Of course, it's imaginary. Now, when you replace it with a coil like this, of course, the same thing will still happen where there'll be a force acting on the side, upward, and then you have another force acting downward. So the same thing is going to happen in both cases. You see? So this is what happens when you place a current carrying loop or current carrying coil in a magnetic field. You're going to produce on that current carrying loop or coil two forces which will constitute a couple rotating the coil or the loop in the magnetic field. You see? So let's talk about the application of electromagnetic field. Electromagnetism. Application of electromagnetic field. Now, the application of electromagnetic field finds its application, number one, in what do you call it? We have number one, electric motor, and then two, we have the moving coil galvanometer. So we are not going to be going into the working principles of these two devices. So electromagnetic field finds its application in these two devices, electric motor and also the moving coil galvanometer. Now the electric motor, you can find it in your fans, your ceiling fans, you know. So yes, that's what you have.